Gone. Good morning. I am ready to start a new class with you. And the first topic that we must talk about is real numbers. Real numbers are all the rationals and all of the irrationals. Well, you say rationals and irrationals. I don't even know what that is. So I'll tell you. The rational numbers are numbers that can be written in the form P over Q, where P and Q are integers. When I say P over Q, I mean P divided by Q. Any number that can be written in fractional form will be called rational. That means that all of the whole numbers can be written with a denominator 1, so they are rational. Again, the real numbers are all the rationals and all the irrationals. And I just shared a definition of the rational numbers with you. The irrational numbers are what we call non-repeating, non-terminating decimals. One way to generate a list of irrational numbers is to take the square root of a number that is not a perfect square. But let me go on and tell you what a perfect square is, and then I'll go back to the definition of irrational numbers. A perfect square is a number that can be factored into two identical factors. 4 is a perfect square. Why? Because you can multiply 2 times 2 and get 4. 25 is a perfect square. Why? Because 5 times 5 is 25. Whenever you take the square root of a perfect square, you get a rational number. Here's what I'm talking about. Square root of 4 is 2. Why? Because 2 times 2 is 4. Square root of 25 is 5. Why? Because 5 times 5 is 25. Now, to generate a list of irrational numbers, you put a non-perfect number under the radical. For example, square root of 2 is irrational. It is a non-repeating, non-terminating decimal. It can be estimated with the decimal 1.414. But in fact, it goes on and on and on, and there's no pattern to the decimal sequence. The square root of 3 is irrational. The square root of 5 is irrational. So again, the real numbers are all of the rationals and all of the irrationals. Now, real numbers are a superset to the whole numbers. What are the whole numbers? 0, 1, 2, 3, ... Real numbers are a superset to the integers. What are the integers? Well, 0, 1, 2, 3, ... -1, -2, -3, ... Negative goes on and on and on, and the positive go on and on and on. The integers are an infinite set. Is that clear? Play this video more than once and take notes as you look at the video. We have real numbers that are prime. A prime number only has 2 divisors, 1 and itself. 1 doesn't qualify because it only has 1 divisor, but 2 is a prime number. What are the 2 divisors? 1 and 2. 3 is a prime number. What are its divisors? Only 2, 1 and 3. 5 is prime. What are its divisors? 1 and 5. Well, you got prime numbers, but we also have what we call composite numbers that can be factored into more than 2 factors or have 3 or more divisors. 12 is composite. You can factor it into 3 times 4, or you can factor it into 3 times 2 times 2. So we have the real numbers, all the rationals, and all the irrationals, but we also have the prime numbers with only 2 divisors, and the composite numbers that have more than 2 divisors. Now, you may want to know more about divisibility of numbers, real numbers. And I will tell you more about that in the next video. Okay,